Welcome to aminacademy.com. In astronomy, let us discuss about Bohr's atomic model. Rutherford model for atom has one serious problem. Maxwell theories of electromagnetic radiation says that when electrons change either speed or the direction of motion, they must emit energy. Orbiting electrons constantly change their direction of motion, so they should emit a constant stream of energy. Applying Maxwell's theory to Rutherford's model, all electrons should spiral into the nucleus of the atom as they lost energy, and this collapse should happen very quickly, about into 10 power minus 16 seconds. It was a Danish physicist, Niels Bohr, who solved the mystery of how electrons remain in orbit. He was trying to develop a model of the atom that would also explain certain regularities observed in the spectrum of hydrogen. He suggested that the spectrum of hydrogen can be understood if we assume that orbits of only certain sizes are possible for the electrons. Bohr further assumed that as long as the electron moves in only one of these allowed orbits, it radiates no energy. Its energy would change only if it moved from one orbit to another. But at the microscopic level of the atom, experiment after experiment has confirmed the validity of Bohr's strange idea. Bohr's suggestions became one of the foundations of the new and much more sophisticated model of the subatomic world called quantum mechanics. In Bohr's model, if the electron moves from one orbit to another closer to the atomic nucleus, it must give up some energy in the form of electromagnetic radiation. That means if the electron moves from one orbit to another closer to the atomic nucleus, that is from outer to inner, it must give up some energy in the form of electromagnetic radiation. If the electron gives from an inner orbit to one farther from the nucleus, however, it requires some additional energy. One way to obtain the necessary energy is to absorb electromagnetic radiation that may be streaming past the atom from an outside source. The key feature of Bohr's model is that each of the permitted electron orbit around a given atom has a certain energy value. We therefore can think of each orbit as an energy level. To move from one orbit to another, which will have its own specific energy values, requires us a change in the electron's energy, a change determined by the difference between two energy values. If the electron goes to a lower level, the energy difference will be given off. That is E equal to hf. The formula E equal to hf is energy emitted is equal to h, a Planck's constant, and f is the frequency. Now we will further discuss about Bohr's atomic model. Bohr's atomic model, a planetary model, depicts electrons orbiting a positively charged nucleus in specific quantized energy level or orbits, and electrons can jump between these orbits by absorbing or emitting energy. That is energy from outer to inner, it emits energy. From outer to inner to outer, it absorbs energy. Quantized energy level. Here, key features of Bohr model. Electrons can only exist in specific energy level or orbit around the nucleus, and these levels are quantized, meaning they have fixed energy values. Electrons in orbits. Electrons orbits the nucleus in fixed circular path similar to planets obtaining the sun, orbiting the sun. Energy transition. Electrons can move between energy levels by absorbing or emitting energy in the form of photons, packets of light. Ground state. The lowest energy level where electrons are closest to the nucleus is called the ground state. Here, this is a ground state. Quantum numbers. The orbits are labeled with integers n equal to 1, 2, 3, 4, 5 like, known as quantum numbers, which represent the energy level. How it explains atomic spectra. When an electron transitions from higher to lower energy level, it emits a photon with energy corresponding to the difference in energy between the two levels. This emitted energy manifests as light of a specific wavelength, which explains the characteristic spectral lines observed when atoms emit light. Some limitations also there in Bohr's model. What are they? Only applicable to hydrogen. Bohr's model successfully explained the spectra of hydrogen, but it failed to accurately predict the spectra of other atoms. Does not account for electron behavior. The model does not explain the wave-like nature of electrons or the probabilistic nature of their location. Simplified view of atom. It's a simplified model that does not fully capture the complexity of atomic structure. So far we discussed about Bohr's atomic model, that is hydrogen atom model. We have done. Please subscribe our YouTube channel.